Hi everybody, my name is Jake Spencer. I'm going to talk about the beauty of code-first migrations. If you want to find me out on GitHub, my name is Jolly Jackal on there. So, a little bit of more info about this. I actually initially learned about it from the Complete ASP.NET MVC5 course by Mosh Hamadani out on Udemy, and it was actually a pretty nice introduction to this. And of course, out on MSDN, you can find more information about it. What is a code-first migration? Well, it's part of Entity Framework. Instead of creating your tables first and then using a generator to generate classes to interface with that off of it, you write the code that describes your model of data, and then off of that, you generate the tables and columns in the table. One of the nice things about being able to do that is if you don't know database stuff that heavily, or you don't have a very complex schema you need on your database, then it provides an easy way to make simple tables with just, basic fields in them and not need to worry heavily about what you're doing with your database. It still does a lot of what you need in the database. It can generate foreign keys and things like that, which I'll show shortly. The basics of it. The way that I've interfaced with it so far is you use the Package Manager console in Visual Studio. You do enable-migrations to enable migrations for your project. And then when you want to add one, say after you've generated a model that is going to be tied to your database, you run add-migration and then give that migration a name. And it will generate a migration off of that, which will include adding columns to your table if it needs to do that, deleting columns, dropping tables, things like that. Lost my train of thought. And then when you want to actually commit those changes to the database, you run update-database, and that will actually run everything, changing your tables in your database. One of the cool things about migrations is that you can roll them back. So it keeps a track of history in your project in Visual Studio, and you can actually go back in time. It's got, I'll show you in a minute what a migration looks like. And there's an up, which is when it applies that migration, and then there's a down when you're reversing that migration. So you can actually go back and forth. So the first thing you need is your model. Obviously this is from an MVC style, and the models tends to represent your data in the database. So you need to create a model, which pretty much it's just a plain class that contains some properties that represent your data. If you write the class properly, it'll actually set up your foreign keys to other tables because you'll use the types that are your other models in it, and you can use an ID and it will be able to tie in your database to know what the foreign keys are between the different models. Here's a basic model, one that I threw together for a project I'm working on. As you can see on here, if you look towards the beginning, you see user ID and user. And part of the convention that Entity Framework is able to do is it knows to tie those together. So even though in this class I can directly access the user, when you look at your database table, it actually only has the key there, which is user ID, and that's a foreign key back to the other table. In this case, you can see I'm using identity user. I'm actually using Microsoft Identity as well for my login credentials. Tying the model to the database. So you write that class, but you need a way to tell Visual Studio or what have you that it ties to the database. So you need a DB context class, and I'll show an example of that on the next slide. But it contains each of the models that you wrote as a DB set. You add your DDB context, the call to it, in your startup.cs configure services method. So this is my DB context that I made for my project. You see I'm inheriting from identity DB context in this case, and that's part of Microsoft Identity. It already has all of the models and everything in it needed for Microsoft Identity. So that way, when I inherit from that and use that, it generates all the needed tables for using Identity as well. And then at the bottom, you'll see that where I have the DB sets, I have one for messages, one for conversation, one for edits. And you'll see that those DB sets each use the message, conversation, and edit models that I generated elsewhere in my code. And then the second part of the code, it's actually that's where in your startup.cs you're including the DB context. So you're calling services.addDB context, and in this case I'm connecting to an SQL database, so I'm giving it my connection string. But I'm using my messaging DB context there, and that's where it's telling your application that that's what it ties to. Data annotations. So if you look, I'll flip back and forth here real quick. The strings on here that are surrounded by brackets, those are data annotations. What data annotations are, they override the default conventions for entity framework. When you have a string in your model, the default convention is to make that a nullable field, and it's going to be nvarchar max. So say you want to limit the size of it and make it a non-nullable field, you have to use data annotations to change that. You use system.componentModel.data annotations to enable them. And then, again, that's just an example of, say, the required annotation. And there's also something called Fluent API, which I know it exists, I haven't used it yet or looked much into it, but it's supposed to be a more flexible version. Data annotations still have some limitations, and if you need a little bit more powerful, you can use Fluent API to do a little bit more specific things. And again, you can see on the last field here, text, I'm making it a required field, so then in the database it'll be not nullable. And then I'm doing string length to 2000, so the length instead of being nvarchar max is going to be 2000. So the other thing, which I guess some people have been wary rather of code first migrations, is because they want to be a little more specific with their SQL. You can actually run Manual SQL as well as part of a migration. You can write whatever SQL statement you want. The use I saw for it in the tutorial I went through was, say, in this case, they were adding movie genres. Well, movie genres aren't really fields that change. You might want them in the database, but action's going to be action. It's not something that you're going to change from time to time. So if you want to just front load those in your database so those fields are available, that's one of the uses for this. And what you can do is outside of when you've created a migration for your models, you can just add a migration, and what it will do, it'll make an empty migration of whatever name you give it, and then you can actually go edit it before you update your database and add your SQL statements in there. And this is what that looks like. This is a migration that was initially empty, and it was called bootstrap genres, is what I called it. And then you see in the up function, it's actually making 4 different SQL calls where it's inserting into the genres table. In this case, I didn't do it down because I didn't really see a purpose to remove them from the database, and you'd have to very specifically remove them from the database, and it just wasn't important for this project. But if you were doing other SQL statements that you would want to reverse when you back off a migration, you could actually edit the down function as well, and that would be what reverses it when you roll back a migration. That's pretty much what I had. If anybody has any questions. That migration, that's where the question was, what's that? Yeah, the question was, how would I run that migration? Right here, where you see update database on here, that's actually the command that after you add a migration, you run update database, and that executes any pending migration. So you could actually have 5 or 6 migrations you haven't applied, and it would step through all of them in order and apply them.
There's a question on the string. Are there any performance losses doing migration this way?
I imagine there probably are. If you looked at the SQL it's generating and edit it yourself off of it, you can do whatever you want to with it. I don't come from a heavy database background, and so it's nice for me because it takes care of some things that I don't have to think about as much. But I would think that if you want a more particular use over your database or a particular way of doing things in your database, you'd probably want to do it yourself. So I would imagine there is, but I'm not actually sure how much there is.
Yeah,
Yeah.
But do you have anything to combat that feeling? Just like,
Mostly, I would say, well, let me see if I can do this without messing up things too much. Kind of make that bigger. So this is a migration that was actually generated by adding a model. So this wasn't anything that I did, but you can see in here where we're actually adding the columns and things like that. So before you execute a migration, this is the migrations folder where it adds each migration, and it will add them, and you can see there's a timestamp on each of them, so it executes them in order. And so before you run the update database, you could actually go into the migration and modify it yourself. And so that way, if you do know the more particulars and you know that something's not quite as efficient as it could be, you could actually go into the migration and modify it before you apply it to the database. So that way you would have more control over what it's doing. Yes?
So when you say add migration, what it's doing is creating one of these files?
Yes, the question was when you do add migration is what it's doing, creating these files. And yes, that's exactly what it does. After you run add migration, it generates these files here. And then you'd run update database to actually apply them. But it actually does it off of, you can see I've got the models folder here, and adding these models as DB sets in my DB context, that's what ties it back to know that it needs to, when you run add migration, parse those and generate a migration or something in your migration off of those.
Do you know how it knows the before state?
What's that?
Like if you change the code and then say add migration, it knows what the current state is, but how does it know the before state?
The question is, when you run add migration, it knows what the current state is. How does it know the before state? From what I can tell from having run it, the first one you make, it doesn't assume any of it exists. It kind of assumes blank. And so it will know, it will generate it as if you're generating brand new tables there and naming them based off of what you've named your models. And then as you create more migrations, it goes back to the last migration you applied and knows how to step from there. Any other questions?
Have you used any of this for unit testing or loading mock data?
Have I used any of this for unit testing or loading mock data? Yes, you can. It's, from what I understood, it's better to not do that, because one of the nice things about this, and I do development both on this laptop I'm using for the presentation and on my desktop. And so one of the nice things about these migrations is that I was able to write it all on my desktop, and then when I wanted to transfer it to my desktop, I just shoved everything to GitHub, pulled it to my laptop, applied the migrations, and it was in the same state as my desktop. And for the unit testing data, I did it manually inserting into the database, just because that way when you get to production state, you can just apply your migrations and your table will be in the state you expect it to be. So you won't have the extra values that would be in there if you put your unit testing data in. Anybody else? All right, well, thank you again. My name's Jake Spencer.